I'm a student in Japan. My name is Ryuta Yamashita. Today, I will be presenting on classification method and its effective use for web advertisement based on pupil fluctuations. Today's table of contents looks like this. Currently, there are many web companies such as Google in the world and Yahoo Japan in Japan. Many of these companies make money by presenting web ads to their users. Advertising revenue is indispensable for running a web company. Many web companies save big data such as ID information, browser history, and product purchase history in order, and to provide users with relevant advertisement. They provide recommendations to users based on that big data. However, this is a problem with the recommendation function that uses these big data. This is a Japanese survey, but in a survey asking, web ads obtrusive and annoying, 88.8% of users answered yes. This shows that the current recommendation system is incomplete. Therefore, we set the final goal of this study. As I introduced earlier, the current recommendation system mainly uses the information that can be obtained online. We wanted to create new recommendation system based on the information available offline in addition to the information available online. We wanted to be able to combine online and offline information to present web ads that users do not experience as intrusive. The offline information focused on in this study is as follows. We choose those because these do not require medical knowledge or skill to handle the devices that acquire the information, and the data can be obtained with easily available devices. These offline information are commonly referred to as multimodal information. For this reason, I will use the word multimodal information in this presentation as well. This study estimated the user's emotions based on facial expression. This study is about using these emotions in a dialogue system. The following study estimates the user's emotion based on pupil movement. The next study utilizes gather movements. This is a study limited to the grid UI of smartphone. This is a study that estimates the user's next target and present web advertisement based on the estimate. We have also investigated many other studies. Based on these studies, we consider that emotion can be estimated from multimodal information. Therefore, we thought it could be applied to recommendation systems. The purpose of this study is to build a new recommendation system to provide web advertisements to users in an appropriate manner. Let me give you an example to illustrate. If users saw an offensive advertisement, we thought they would react in the following ways. Their facial expressions would deteriorate, their gazes would shifty eyes, and so on. This experiment was conducted to obtain data on subjects' response to multimodal information when they viewed the advertisement. Information on the subject are as follows. We gave the subject a task in the experiment. The task is to operate the two-choice quiz system. Here is the screen of the quiz system. The genre of quizzes is trivia. The question text is displayed here. The correct answer choices are displayed here. We prepared 738 such questions and displayed them randomly. While the subject is solving this quiz, we show the advertisement to subject. We have prepared three types of ads. I will describe the three types. The first is banner advertising. Displays an image at the bottom of the screen that imitates a banner ad. The second is front ads. This ad will be displayed on the front. This ad interfaces with the subject's operation. Subject must press the close button to hide the ads in order to continue answering. The third is click ignore ads. We have added certain function to the front ads. That function is to ignore one or more clicks of the close button. The number of times to ignore was set to 1 to 6 randomly. We control the order of appearance and frequency of the above three types of displaying ads to avoid bias. And we created a measure of stimulation intensity for these three ads. Stimulation intensity in the degree to which the subject is observed by the operation. We set it as one of the perspectives of our analysis. We hypothesized that stimulation intensity would be stronger for banner ads, front ads, and click ignore ads in that order. Next, we will discuss the images used in ads. Two types of images are available. We use a dataset called OASIS. OASIS is a medical dataset which is a numerical representing of human feelings. In our study, we selected 30 of these positive images and 30 of these negative images. We displayed them randomly among 30 pictures at the time of our display. We also controlled for random bias in the type of images displayed. I described a total of 6 types, 3 different ad display methods, and 2 different ad images. We added no ad for comparison for a total of 7 different analysis sections. We repeat these 3 times to get multiple data. We get data 21 times per subject. We obtained these 6 types of multimodal information in this study. However, I will describe in this presentation the result of my analysis using pupil size changes and clicks. Other multimodal information are obtained for collaborators. I will now describe an analysis that focuses on pupil size and mouse clicks. First, we found blink and momentary measurement errors in our analysis of pupil size. Therefore, we pre-processed the pupil size data. First, we excluded outliers. Then, we did the interpolation process. Next, we resampled to 60 Hz. Next, we averaged the left eyes and right eyes data at the same time. Finally, we standardized with a mean of 0 and a variance of 1. This pre-processed data is the target of the analysis. We found a characteristic movement in this data. We analyzed our data from 3 perspectives. We focused on the original data, frequency component, and long short-term moving averages. I will explain one by one. Here is an example of the data we obtained. First, I will explain this graph. The experimental time progresses according to left to right. The vertical axis represents the size of the data. The acquired data is shown like this. The background color represents the time the ad is presented to subject. Here I display the data I got. The original data is moving finely, and there was an increasing trend in the time the ads were presented. We considered fine and large movement to be characteristic. Therefore, we analyzed the signal by breaking it down into its frequency components. First, I will figure out the low frequency region. This low frequency region is 0 to 0.1 Hz. As you can see, In the low frequency range, there was a tendency for increases and decreases to switch during the display of some ads. Next, the frequency components in the middle range is illustrated. This is 0.1 to 1.0 Hz. Some signals existed that appeared to be changing in response to the display of advertisement. This is different from of data than we have seen in the past. Finally, the high frequency region is shown in the figure. The high frequency range is 1 to 10 Hz. High frequency signals are finely tuned. Therefore, we decided it would be better to check the power. We found features from the high frequency power that differ from previous signals. Next, we focused on the short-term and long-term moving averages. We calculated the difference between the two signals. This analysis is commonly used technique for capturing stock price trends. I show the calculation result on the screen. We considered that there is a different movement from the analysis by frequency component. However, we found a move to response to the ads as before. The graph so far shows one of the subjects as an example. Other subjects showed similar trends. In order to objectively represent and confirm the characteristic pupil size movement up to this point, we decided to investigate the characteristic using machine learning. There are many methods for machine learning. We choose to use self-organizing map, SOM, among them. SOM is a machine learning technique that maps features to neurons arranged on a plate. We make the SOM run the features. The signals presented so far are time series data. Time series data is difficult to handle in SOM. Therefore, we determine a certain interval and calculate the average value of signal within that interval. In this case, we set the interval to 8 seconds after the ad is displayed. These 5 data are used to train the SOM. Here is the result of the training using SOM. First, I will briefly explain how I use the SOM to analyze the result before detailing the result of my analysis. The mapped position is represented by a circle. There is a label next to the circle. The labels are lined with alphabets and numbers. The alphabet represents the subject. The numbers represent the type of advertising. This is synonymous with numbers and indicates the type of ads. In addition, subject S is not present in the figure. When we checked the signal, subject S had hair over her eyes. Subject S was excluded from the analysis in the SOM because little pupil data was obtained. In other words, the SOM is trained only on successfully acquired data. Finally, I will discuss the background color of the SOM. Light background colors indicate that the features are far from each other. Conversely, dark background colors indicate that the features are close to each other. That's all for the basic explanation of SOM. Next, I will discuss the result of my analysis. As you can see, the colors tend to cluster in each area. Red colors are clustered at the bottom of the screen. Blue colors from the center to the right. And green and gray colors at the upper left. Each I will explain in detail. Please pay attention to bottom of screen. This is an area with light background color. Number 5 and 6, i.e. click ignore ads are quite common. The results show a tendency for click ignore ads to have distance characteristic from other ads. The background color of the area where number 5 and 6 are present is also light. indicating that the click-ignore ads also have relatively distant characteristics from each other. Furthermore, since number 5 and 6 are mixed, it can be said that there was not much distance between positive and negative images from this study. Please pay attention to center of screen. We can see that there are many blue colors, i.e. front ads. Indeed, there is a mixture of non-blue colors. However, most of these are composed of blue colors. Front ads area tend to have light blue positive image at the top and blue negative images at the bottom, unlike click-ignore ads. This area has a slightly darker background color. It indicates that their characteristics are close to each other. Finally, please pay attention to top of screen. There is a mix of greenish and gray, i.e. banner ads and no ads. Their features tend to be close and not clearly separable. However, this area is the farthest away from click-ignore ads. These are the results of the sum analysis of pupil size 10 in 19 subjects. We are generally able to show that pupil size changes characteristically with ad type. This indicates that strong advertising stimulus may be inferred from pupil size. However, we found that some ads did not cluster well. This will be analyzed in detail in future issues. Pupil size may also be difficult to characterize depending on positive and negative images. However, we also found that front ads tend to be easier to categorize as positive or negative images. Next, we attempted to analyze the negative and positive images separately. First, here is a result of the negative image analysis. Please pay attention to bottom of screen. Many browns are gathered. Most click-ignore ads are clustered together. Please pay attention to center of screen. Blue, i.e. front ads are clustered. Next, please pay attention to left side of screen. Green, i.e. banner ads are gathered. Finally, please pay attention to top of screen. Gray, i.e. no ads are gathered. As described above, we limited our analysis to negative images. In that case, we found a characteristic tendency for pupil size to change as the ad changed. Next, I present the classification result restricted to positive images. In particular, there is a mix of 3 ads from the center to the top. In this case, the boundaries of the advertisement are ambiguous. However, red click-ignore ads tend to have relatively clear boundaries. Thus, positive images were more difficult to classify than negative images. This study is to build a new recommendation system to provide web advertisement to users in an appropriate manner. We found that changes in the pupil size can be classified to a certain extent based on the learning result of the sum. Differences in the way the advertisements are presented affect the changes in pupil size. Among advertising stimuli, click-ignore ads shows significantly more distance characteristics. Differences in the images used in front ads are likely to affect changes in pupil size. We are planning to set up more rigorous conditions for the next experiment. We will conduct a detailed analysis of advertising stimulus that we are unable to correctly classify and solve the reason. We will also find characteristic movements of multimodal information other than pupil fluctuations. Thank you for listening.